again, this is RC Jim, and we got some very helpful things for you today, I think. Now we're going to be testing electric motors with regard to the watts that they consume, the amperage, thrust that they produce with different props, and it's really some very practical matters with regard to testing. Now this Corsair today, I had its maiden flight. And boy did it fly nice, really beautiful, very, very happy with it. But I noticed it was a bit underpowered. Now, it did have kind of scale-like characteristics, so I think I'm probably going to leave it as it is. But I thought I'd just investigate a bit as to what sort of power, what sort of thrust it's generating, what sort of amperage it's drawing and all of that, just to get a feel for where it's at. So we'll be testing this plane today for the thrust. We'll also be setting up a little test rig that I've built. A little thing that helps us to be able to put on a motor, have an ESC and a battery and a receiver, and put on different props for the motor, test the RPM, the thrust that it's generating, how many amps it's drawing. And again, that's very practical. As for the conversion that I'm doing, where I'm going to use this motor, I want to develop an equivalent thrust for a 46 nitro motor, but I've got to be careful that I don't overdraw the amps on this, and boy does it make a big difference. So I'll be showing you all of that on this video, so stay tuned. I think you'll find it really helpful. As you look at the setup here, we've got the plane in place. We've got it on a stand that's suitable, wide enough for the thing, and as you see for my rig here, I had to put an extra board on there that was wide enough for it. We've got this rail across the front to sort of act as a safety should something happen when it's not tied down at the back. Of course, we'll have our battery. We'll want to check the condition of the battery with the checker. We've got a watt meter that we're going to use to measure the current going into the battery. We've got a scale back here that's going to be used to measure how many grams of thrust is being generated by the motor. Of course, we've got a transmitter to be able to control things. I've got it tied up with this rig at the back. I've taken a couple of nylon straps. I've used a hot nail to put holes in the end so it's nice and sealed off. It's not going to fray loose. I've tied it onto the strap here, and I've got it hooked onto a brace here at the back. Now the important thing here is that it's in line with the center line of the motor. Originally when I did this, I tried hooking it onto the tail wheel down at the bottom, and the back wanted to raise up, and it was kind of going crooked a little bit, and I thought, yeah, that's probably not terribly accurate. So I would much rather have something that's right directly in line so that when the plane is pulling on it, everything is straight and we get a good accurate reading. Because this is just a hook back here, I've added a little bit of a redundancy with my normal restraining strap. And of course, as you can see, this bracket is held on by a couple of clamps. So that's our rig, so let's get it all hooked up and let's see how it goes. It's a good idea when you're doing this to stay nice and safe. Safety glasses, earmuffs, all that kind of thing. Also keep in mind that this thing is going to blow a lot of air backwards, so you're going to want to clear everything behind it. We get our transmitter turned on to course, make sure we got the right plane, that's all looking good. We then get our battery up in the plane, and not terribly fussed as to whether it's in the total final position or not. The meter is going to go between the battery and the ESC. So you got the power leads from the ESC, you got the power leads from the battery, and our meter is going to go in between the two. Make sure the prop's clear before you do the final plug-in. Okay, that all looks good. It's a challenge getting this thing to sit the right side up so where you can see it. Okay, so we've got all of that. We have a check of the condition of our battery. It's on 16.72 volts, 98%. So I take note of that. Okay. Now I'm going to stick that in my pocket so it doesn't blow away. I've got a tachometer that I'm going to use to measure the RPM. Now note with these, they're measuring pulses of light. So if you got the, especially the fluorescent lights going, it'll actually measure 50 cycles per second or 60 cycles per second, depending on what it is, and interpret that into RPM. So I like to do it outside, so I've got here out here at the entrance of the garage. Also note that you pick a 2-bladed or a 3-bladed prop, and in this particular case with a 4-bladed prop, it means that it's going to show double what the actual RPM is. So I'm going to have to cut it in half. So we got that ready, the next thing to note with my meter that I've got, for measuring the force spec here, this thing locks the value when the value steadies. So you don't want to go up part way and stop on the throttle and then go the rest of the way, because it will have locked in the lower value. You want to steadily go right up to the maximum value. Another thing is that if you haven't run your motor before on the plane, you better check to make sure it goes the right direction. Okay, so hold the plane when you first start it, make sure it's blowing air back at you. Okay, so with that, let's have a go. Okay, I turn on the power. Okay, that's all set to go. And 47. 47 amps, and I didn't measure the RPM. Okay, so we'll give that another go. We'll press the tare button to zero that out. Okay, 10,200, so 5,100 RPM. Okay, and that did vary a fair bit. These things do suck down the battery in a hurry. So it's interesting to check that afterwards as well. It's already down to 73% from 98. Well, 74, it's recovering a little bit. 76. So that's the basic idea of how we do it with a plane. And of course you could try different props and see what happens with different props. Naturally you want to think about what your rating is on the motor. I'll have to look up this motor and see what it is, but it's an 80 amp ESC, so we're well within the range of what the ESC can do. Basically, as you go to a bigger prop, it's going to draw more current and give you more thrust, but you want to make sure that you don't get above what the motor can handle and what the ESC can handle. One additional thought as we are measuring the thrust and the performance of the airplane is just what we're having to pull through the air. And it's a good idea to actually weigh your airplane. So since you've got the rig all set up here, all you have to do, well, first off, turn on your meter. Make sure it's zeroed out with a hook on it. And then we pick up the plane. And 2785 is the weight of that particular plane. Let's double check that. Tear. Once again. 2785. So with a plane weighing 2,785 grams and generating 2,865 grams of thrust, that's just a little bit over 1-to-1, which is very appropriate for a sport plane. So that tells me that I'm reasonably okay in terms of what we've got. So let's next look at our little test rig cart. Well, let's have a look at our setup here. Here we've got our cart, just a very simple wood block. I put a few Velcro hook dots down there. Got our ESC, stuck it Velcro onto one of the dots, just kind of hold it there. Got our motor on the front, just on a ordinary block of wood up there to be able to bolt different motors on there. Again, we got our safety rail in place, making sure that the prop is clear of that on the outside. Just ordinary airplane wheels that I put on here. Got nails into a hole that I've drilled with a drill press nice and straight in the back, and got screws on the front. They don't have to roll real easy, but just needs to make sure that they're not going to inhibit anything as far as measuring the weight. We've got our scale back here to measure the force. You notice I've got a wood block underneath it. I want it to be pulling nice and straight on there, and I've got it secured from the back right down the middle, so this can be nice and square and come just short of the timber up here when it's going full blast. By having these sides on here, we can fit in the battery and the watt meter. We'll get those in place. Actually, I like to have the power leads away from the receiver. Okay. And we got a little rubber band on there to help hold this guy in place. Okay, so we make sure the throttle's down, our safety switch is on, we fire up the transmitter, make sure we've got the right model there. We just sort of hold on to this, make sure that the prop is clear as we hook up the power. Okay, we double check the direction of rotation. Back at me. Okay, so we double check our battery. We'll have enough at least for one test here after a period of time. We've got our tachometer. We are going to record the RPM, the amperage, and the force of the thrust. Okay, so we make sure that that's zeroed out, and we are all set to go. Okay, so that's the basic idea of how it goes. I'll then share with you some of the results that we've done with the test on this motor, just to give you an idea of how the different props affect the amps and the thrust. So here's the data that we got on just a few of the props that we have on hand. So you can see the three-bladed prop, the 10x7x3, only generated 1610 grams of thrust at 9,700 RPM. I didn't measure the amperage on that one. 12x7.5 two-bladed, 2385 grams. And the 15x8 electric prop, the 3675 grams at 7,600 RPM. But have a look now at the amps. Now the 10x7x3, that would be less than the second one there, in that it's turning higher RPM, which means lesser load, so that's not going to be a problem. 46 amps, that's getting up there, but the peak for this motor is just 55 amps. So the 64 amps is definitely too much. We got to back off. So how did we get ourselves in this situation? Well, I'm not exactly sure to turn it back, but just looking on the Dualsky website where they talk about their tuning packs, they have this 3520 with a 720 kV motor, which is just a little bit more than the 680 that I ended up with, that they describe as a 50 class aerobatic pack. Well, it's a 32 equivalent, not a 50. No wonder we're confused. So what we should have been looking at is the specs for the motor itself. So as we look at the spec sheet here, you can see down at the bottom that the equivalent is a 32 to 40 two-stroke. So yeah, it's a 40 class plane that we're looking at, so it's not too far off, but certainly less than the 46 that we had on it. While we're here on this page, we also note that for the 680 kV motor that the max burst current is 55 amps. Max efficiency current is 33 amps. Now, as they talk about max efficiency, that doesn't necessarily mean that's the maximum for, continuous use. It actually is a bit curious as to just exactly what they mean. Note that as you go to the higher kV motors, the amperage goes up. So we now have a look at the data that they have for the 4S battery on the 680 kV motor. Interesting to note, we did test a APC 15x8E prop. We got 3675 grams of thrust at 64 amps. So we look at their chart here, that should have been, perhaps something around 4,000 grams. But hey, manufacturers typically manage to get a bit more out of it than most of us do in practicality. But we do note that there is a problem with regard to the amperage. Our motor is rated at a maximum 55 amps for a 15-second burst. So we can't go to 7,500, 7,700 RPM, and that's what that motor could do. And I do find it interesting that they are providing data on two props here that, according to the specs, are not suitable for that particular motor. It is interesting, in my notebook, I've got written down 14x4 recommended prop. And I'm not sure where I got that, but that's probably much more appropriate for this particular motor. So where do we go from here? Well, if you haven't bought the motor yet, and I might buy another one to, fit this bill, what you'd be looking at is something with a higher kV rating. So the highest kV rating for the Dualsky 3520 is a 1020 kV. And as we look at the specs here, well, first off, thinking about the specs, it was 80 amps maximum. And so looking at the performance data here, we see that they're all under 80 amps. So that's encouraging to see that. And then you'll also see that you got thrust that goes up to, 3,900 grams for the 12x6 prop. OS Max 46 develops about 3,261 grams. So, hey, here we got a motor that's, said to be a 32 equivalent, and we can get 46 performance out of it if we choose the right kV value, and we can do it with a 12-inch prop. It just means it's going to be buzzing around real fast, similar to what the nitro motor would do. One last thing that I'll note here is that in the specs, they say that this is good for 3 to 5 cells. On the performance data, they only show 3 and 4 cells. So it's a bit of a mystery as to exactly what would be the outcome with 5 cells. But we would note that the RPM should be about 25% higher. You'd be swinging a slightly smaller prop. And there might be an interesting solution there. And that's something you'll have to use the test rig to test it out and see what happens, since they're not telling you what's going to happen. Well, thank you again for watching today. Trust that this has been a help to you. Be sure and subscribe to our channel, because you can find a lot of other interesting things. So down there at the bottom, you'll find a little circle to click on to be able to subscribe, and we keep on delivering things that we think are going to be really helpful to you. As we do that, give us feedback. let us know what you think, what you'd like to know about and hear about and be shown, and we'll do our best to deliver it for you. Thank you very much, and have a great day.